guys. Next set of notes. This one's not going to be as long, at least it's not supposed to be. But there's a couple things that you should have noticed from that activity that you did in terms of these types of reactions, that there are 5 different types. And being able to recognize them is relatively simple just by looking at what's happening. So the first type of the 5 is something called the combination or synthesis reaction. The word synthesis means to synthesize, which means to combine, which is what combination is. And what happens is that there are 2 substances that combine to form one new substance. So this equation right here shows us what can happen. Substance A plus substance B combine to form one single substance. So this is like the little, I don't want to say skeleton equation, but it's like the blueprint for what a synthesis reaction looks like. So you could have something as simple as sodium plus chlorine combines to create sodium chloride. 2 things combine to form one larger. What you may have seen from the activity that you did and one of the questions that was asked of you was, do you only have to have 2 elements to combine to form one compound? And the answer is no. You could have 2 compounds or 2 molecules combined to form one singular. One of the examples in your activity was MgO plus H2O. These can combine to form MgOH2. Magnesium oxide and water can combine to form magnesium hydroxide. Now, these are not balanced. I'm not going to spend the time to balance them. You guys already know how to do that. This is just how you recognize what kind of reaction it is. So here would be A plus B combines to form compound AB. You put them together. All right. Next type is decomposition, and this is the opposite of combination. And the word decomposition, or to decompose, is when a single reactant, which is always going to be a compound, aka a molecule, okay, is broken down into 2 or more, could be 3, it could be 4, 2 or more products. So that's like taking one large compound, compound AB, and breaking it down, decomposing it into smaller pieces, A plus B. Okay, an example of this would be something like K3N is going to decompose into what? Well, if we have this large molecule and it decomposes, it's going to decompose into potassium plus nitrogen. And now since nitrogen is a diatomic, got to decompose into N2. Again, it doesn't have to be one molecule splitting up into individual atoms or their smaller pieces. It could be a large molecule splitting up into more molecules. So it could be something like KClO3 breaking down into KCl and O2. Now again, these are not balanced. You will have to eventually go in and balance them, but I'm not going to spend the time on doing that right now. Next example are single replacements. And single replacement, single means one. One thing is replaced. And when this happens, this is when an element, which is usually a metal, replaces a metal. I don't know why that's a metal, which is usually a cation in a compound. So if we look here, something is going to start with someone and it's going to end up switching. So typically in this reaction, A would be a cation, B would be a cation, and C would be an anion. And what happens is this anion who's with B is going to leave B to go be with A. Because here's our cation, here's our cation, here's our anion. So our anion leaves the first cation it's with to go be with the other one. So that's what happens in single replacement. One thing is moving, and usually it's the anion or the negative that leaves the positive that it's with to go be with the other positive. So an example of that would be something like Zn plus CuCl2, which would make ZnCl2 plus Cu. Zinc plus copper chloride makes zinc chloride, and copper. So here you're just dealing with metals, zinc and copper, and then chlorine is leaving copper to go be with zinc. Now, sometimes it's just simple as metals and nonmetals, but sometimes we also are dealing with polyatomics. So one example would be Mg, magnesium, plus CuSO4, which is copper sulfate. Now, we can kind of predict what's going to happen. What would happen? Well, SO4 is our anion, it's our negative, and it's with copper. So something's going to jump. SO4 is going to leave copper to go be with magnesium. So we would end up with MgSO4 plus Cu, copper. Now, why can copper and magnesium not end up together? Well, if you remember, we have two positives and one negative, and you cannot put magnesium, copper, which are both cations, they're both positives, together. It just doesn't work that way. All right. Up next, we have double replacement. And now double replacement is when two things are being replaced. Two ions exchange between two compounds. So instead of having just one jumping, now it's two things that are going to be happening. And so if we take a look at A, B, and C, D, what we should see is A is our positive, B is a negative. Cation, anion. C is a cation, D is an anion. And what we should expect is that the positives and the negatives are going to switch partners, which does happen. A ends up with D, positive, negative, and C ends up with B, positive, negative. I like to call this wife swap. If you've ever seen the show Wife Swap, that's kind of what happens. We start with two couples and they switch partners. Okay? Kind of stupid, but I don't know. That's how I always remembered it. So double replacement, a couple of examples for double replacement. You could have something as simple as FeS, iron sulfide, plus HCl, hydrogen chloride or hydrochloric acid. So we can kind of, just by looking at this, predict who's going to be with who. H is going to end up with S, and Fe and Cl are going to end up together. Okay, so positive, negative, positive, negative, positive, negative, positive, negative. All right, and one more example. Let's do, what was one that I wanted to do? I guess we can do this one. So if we had like SrCl2 plus AgNO3, double replacement, we would end up with SrNO3 2 plus AgCl. Okay, and I know how to write these reactions. You actually should know how to write these reactions, and these little subscripts are coming from bonding. But right now, what I'm really going to be asking you to do is to be able to identify, if I gave you a list of these, be able to identify this one's combination, this one's single replacement, this one's double replacement, based on how many things are moving. All right, last but not least is combustion. And combustion is another fancy word for explosion. And what happens in an explosion is, on a combustion reaction, is a hydrocarbon, carbon, hydrogen, reacts with this. What do you think this is? This is oxygen, O2 specifically, to always produce what? What's happening? What's being produced? CO2 and H2O. Now, the hydrocarbon right here, it's CXHY. That's because C can be any number and H can be any number. You could have CH, you could have C2H2, you could have CH2, you could have C6H10. It really couldn't be any subscript. And the different subscripts are going to be different numbers for different subscripts or different compounds. And if you remember from the IMF lab that you guys did, you started with CH, then there was C2H2, there was C4H4, and they were different alcohols and different gases. All right, so for example, let's do an example right here. We could have something like CH4 plus O2, which would make CO2 and H2O. Oh, that's terrible. So if you see a carbon hydrogen compound plus oxygen and your products are CO2 and H2O, then you have a combustion reaction. And honestly, if you ever see a product that is CO2 and H2O, it's more than likely going to be a combustion, but you have to check to make sure you have a hydrocarbon, a carbon hydrogen compound, and oxygen, and that will tell you whether it is a combustion reaction or not. All right. So what you guys are going to do is were your notes for types of reaction. Now on your worksheets, if you want practice for this, worksheet number 5 is the one that goes along with it. So what you're supposed to do on the worksheet is here, you're going to identify the type of reaction, and you're just labeling what kind of a reaction it is. So in these little blanks, you're going to label and abbreviate type of reaction. So combination or synthesis, you can label it either way. Decomposition, you would label as a D. Single replacement is SR. Double replacement is DR. And actually combustion makes a C. So make combination synthesis look like this, or write as just a singular old S. So for example, if I'm looking at this one, I have H2 plus Cl2 makes HCl. So what would that be? That would be a combination or synthesis reaction. So right here, I would write CS combination synthesis. And then next step, you have to balance. Okay, so you don't have to do all worksheet 5. Just do a couple. See where you're at, balance. And honestly, if you got the balancing part done, then maybe pick a couple of them, label which ones are which, and that's really all you have to do. Hopefully you watched this before the lab. That's what we were doing on Monday and Tuesday, but like I said, this puzzle is not due until Wednesday. So